Good morning and welcome. This is Federico Lucifredi, Product Management Director for the Ceph Storage platform at Red Hat. And I'm joined by Sage Weil from the Office of the CTO, founder of the Ceph project. Today, we're going to give you a preview of what is coming with Ceph over the next year, spanning both enterprise products as well as the upstream project. First, we're going to have a 3-minute introduction as to what Ceph is for those of you that are wandering into the topic for the first time. Ceph is, simply speaking, a software-defined storage system. Deployed on commodity hardware, we do not use custom iron, and designed to build infrastructure with. Cloud native is a bit of an overused term, so I prefer to say that Ceph is just used to build cloud infrastructure with OpenStack, with Kubernetes, sometimes with both. Ceph's claim to fame is its architecture, which is designed to be infinitely scalable, and to do so with scale-out dynamics, meaning we add medium-sized nodes incrementally. We do not replace nodes with bigger nodes as is done in a scale-up fashion. We think of Ceph as the Linux of storage, and it is an apt metaphor for the project's ambition and flexibility. For covering block, object, and file storage, like Linux, we keep adding use cases. But you have to look at the evolution of Linux in the last 2 decades, starting with web servers, databases, print servers. And 20 years later, Linux is everywhere and is the best solution for everything between smartwatches and supercomputers. Today, Ceph is the best solution in 3 areas. OpenStack storage, where we dominate the market by a wide margin, according to every user survey ever published by the foundation between 2014 and today. The second use case is Amazon AWS S3 compatible on-premise storage, essentially building hybrid clouds. Our legal team does not like me making promises about compatibility, but I can safely say that those competitors of ours who do like to make these representations use the S3 test suite that we developed to make those assessments. So that must say something about our compatibility as well. Here we're looking at really large storage clusters in the tens and sometimes 50s of petabytes. Finally, introduced last year and already exceeding the 500 customer mark, OpenShift Container Storage is our solution for Kubernetes persistence, providing PVs to OpenShift, which are self-managed by the Rook operator. More use cases are supported, ranging from backup storage, backup backend storage, certified by all major backup vendors, to iSCSI and NFS protocols, to VMware and coming soon Windows storage. But the 3 areas highlighted here are our strengths and where we are both market leading in share and in technology. The Red Hat Ceph Storage product is meant to be the complete solution for a customer building Ceph-based infrastructure. With a 3-year life cycle for releases, extensible to 5 years under the well-known Red Hat ELS program, where customers require it, and with our storage consultants ready to assist for custom configuration or performance work, or even migration from other solutions. And with the support team on call 24/7 to assist you should you need it. So that's the Ceph in 3 minutes nutshell. Now let's go and see what is coming this July with Red Hat Ceph Storage 5, our infrastructure storage product. There are more than 67 new features in our HCS 5, and we cannot discuss them all in the time at hand. So we're going to group them in 4 interest areas: functionality, new functionality, security, performance, and efficiency improvements. So let's start with functionality. The new integrated control plane is the biggest change we are making to how Ceph is managed, starting with 5.0. Called Ceph ADM, the new management system is built into Ceph and inherently aware of the state of the cluster, making node and service additions a breeze. We're very fond of Ansible, which has carried us as our control plane since our HCS version 2, the first Red Hat product installed using Ansible, the very first. But today, to reach the next level, we need to integrate the control plane with the storage system itself, further than is possible with an external tool. Ansible-loving administrators, fear not. We will introduce a new set of playbooks, which we will call Ceph ADM Ansible in the near future, to manage Ceph ADM from Ansible if you are interested in managing your whole data center from Ansible. But in the meantime, we hope that you will look at Ceph ADM and use all the resources that have been published over the beta program as blogs, showcasing how this all works. You will be surprised by how easy it is. So, manageability features. Beyond Ceph ADM and digging deeper into manageability, the integrated monitoring and management dashboard is acquiring 2 new modules for OSD replacement workflows and RGW multi-site monitoring. Notably, failed drive replacement was a pain point customers have shared with me repeatedly. And it is now seamless both in the UI and in the CLI. The latter being a feature of Ceph ADM, where you can replace a drive relying on the fact that Ceph ADM knows the whole configuration, including encryption and keys, seamlessly with effectively one command. And if you prefer UI, there is a wizard that does so for you from the UI. So exceedingly streamlined. Another item that needs to be highlighted here is the stable status that we are announcing for the management API. For customers that want ultimate control, they can now script the management API directly with the assurance that they will be able to use those scripts for the life cycle of a release up to 5 years without needing change of or requalification as they perform errata updates or minor release updates. New CephFS functionality includes support for the NFS protocol through a new dedicated gateway. This opens the door for a bevy of new use cases, and we need to be careful not to tackle too much at once. So our initial priorities are here. Over the coming year, with the 5x point releases, the first thing will be migration support for GlusterFS customers, support for artificial intelligence and machine learning use cases where the customer is not yet mature in their use of object stores and prefers to rely on a file system-based option. And with Ceph, they have both out of the same cluster, so they can start with one and migrate to the other. And what we call HPC nearline, large data set storage for HPC use cases that does not necessarily require the highest of performance as is provided by HPC-specific file systems. Erasure coding support has been added to CephFS for this release, completing the gamut of data reduction options available to customers, including Replica 2 for solid state, Replica 3, EC for RBD, object, and CephFS, as well as data compression at the backend level and at ingestion time in RGW. The introduction of georeplication to CephFS rounds up the DR story for Ceph, with all 3 data access modalities now providing a DR capability, where data can be relayed between independent clusters as needed. It is important to note that Ceph is highly available and highly resilient inherently with a single cluster. All these enhancements are aimed at multi-cluster configurations where customers have data at multiple sites for risk management or regulatory compliance reasons. On the RBD front, new RBD capabilities are headlined by the introduction of a new mode of operation to RBD Mirror. RBD Mirror has provided Ceph administrators with disaster recovery capability in streaming mode for many years, with changes managed at the point-in-time consistent stream of changes replicating between independent clusters. The new snapshot-based option provides a lower cost, lower overhead capability where snapshots can be asynchronously migrated between clusters. While this mode delivers a less aggressive RPO and RTO objective, it also imposes no performance overhead for DR capability, significantly reducing the cost of DR deployments. The business benefits of the new functionality, therefore, are additionally to the lower cost of DR and the facilitated migration I just illustrated, a reduced learning curve for operators of a Ceph cluster, as you no longer need to learn Ansible to operate a cluster. Additional protocol support, enabling new value-add use cases to be explored. And the density of cluster being maximized by containerized cluster setups. Yes, we are doing away with RPM, starting with RHCS5. We have been deploying containerized clusters since release 3, and it's the way of the future because it enables co-location of daemons, and so it's becoming the exclusive option with RHCS5. Switching to performance. The most impressive advance here is the improvement in block performance, with libRBD-based clients enjoying up to 80% faster performance. On the object side, impressive results in performance and scale were delivered using spinning Rust hard drives, as detailed in a joint white paper released with Seagate. Tooling-wise, the existing RBD top tool is being joined by an equivalent CephFS top tool, and you can guess what that does. So, the block performance improvement was tested end-to-end with an OpenStack cluster by our friends in the virtualization team, and we hope to be releasing a blog with full details shortly. For this discussion, we'll sum it up as follows. The libRBD data path was streamlined client-side, and it is showing an 80% performance increase as seen by a synthetic workload hosting in an OpenStack virtual machine. This is a full stack measurement end-to-end. It's not a pure libRBD benchmark, which is what makes this so remarkable. A significant overhaul of cache architecture has taken place in the Octopus and Pacific releases, including a new read-only large cache meant for large objects. And this is targeted at virtual machines and basically keeping in memory hot virtual machines that are being constantly accessed. The right side has been replaced by an improved in-memory write-around cache, which is much smaller. It no longer serves reads. The reads are coming from the page cache, and it's simply dedicated to batching writes. A third cache that is being jointly worked with the Intel team is an Optane dedicated, or properly an Optane aware cache that is a write-back cache at the client side. As it acknowledges the writes locally and then writes them back to the cluster, it has different failure modes than standard Ceph. However, it is game-changing in terms of latency, write latency specifically. So if you have a write latency workload, we have something new in store for you. A write latency sensitive workload. We have something new in store for you. This is entering in 5 as a tech preview, with some sites receiving support exceptions, and then we will see when it rolls to GA later in cycle. Further on the performance story is the work that I already mentioned done with Seagate. This is scale work where 10 billion objects were ingested in a relatively small 10-node cluster. This has achieved amazing levels of throughput. And I want to call out that this is not solid-state storage. This is hard disks. So the economics of this are remarkable, and the performance is equally remarkable. I invite you to download the white paper, and that's on the Red Hat website, covering all the details. One last front of performance is the IO 500 results that were posted in the last round of this HPC benchmark. I believe our testing placed 21st in the 20s, and full study is posted below. We're highlighting CephFS ephemeral pinning as a key bit of functionality that enabled this result, which is significantly better than previously posted CephFS benchmarks. So summing up performance on the business front, improved capabilities on the same hardware, and better economics requirements because you have lower footprint needs headline the business benefits, obviously. The ability to start small and build a bigger cluster to scale out dynamics are the other factor that I would highlight here. Switching gears, and let's go into security, which is the area that has seen the most changes. We are introducing a warm semantics to Ceph through the S3 object lock functionality. We're supporting FIPS 140-2 cryptography, starting with this release, and going back to releases that that can leverage certified RHEL versions and that have been validated by the appropriate agency. Enhanced access control functionality has been introduced, as well as SSE KMS granular object encryption. These are RGW enhancements for those of you that are not object users, as well as support for external authentication and key management, which has been something that we have been looking at for a while. So let's dig deeper into these one by one. Worm, so write-only object store is now supported. The feature here is labeled as governance, as the feature has not been certified yet, which we'll refer to as Worm compliance. Worm compliance is scheduled for next year. Worm governance, so the functionality part, is available today. And this is particularly interesting as the certification is really US and in some cases EU requirement, but it's not something that's used worldwide. So it just makes sense for us to make the functionality supported while we're pursuing the certification. The support for the FIPS 140-2 cryptography standard is equally geographically related. This is a US federal government certification of cryptography. This is derived from the use of libraries shipping in RHEL. Right now, the libraries in RHEL 8.1 are certified. As DISA catches up with new versions of the operating system, you will see newer versions of RHEL being available for FIPS 142 deployments. DISA has been behind, as they are also the agency that worked on securing last year's federal elections. So they have some work to do to catch up. There is usually some lag to the certification, but it's not as large as it is right now. External authentication integration is the use of key management hosted by external providers. HashiCorp Vault is the most visible here. IBM SKLM, as well as OpenStack Barbican are available as option, as well as support for the OpenID Connect protocol. Here, what stands out is typically a requirement for key rotation, where the customers want to manage regular replacement of keys, and they usually choose to use Vault for this purpose. OpenStack Barbican is interesting in this context because it also provides support for HMAC. I'm sorry, for hardware-based key management units like Gemalto and the like. So that is an additional option for hardware-based providers. So rounding up with the business benefits here, enhancements to access control were discussed at length. WARM is not only interesting for future compliance use cases, but also just for governance purposes, including for things like protection from ransomware that's been hitting the headlines quite a bit lately. Finally, availability of FIPS 140 is relevant to US government suppliers that need to undergo FedRAMP certification, and this is a key requirement for them. And so we're happy to be providing the one more building block. Efficiency spans different areas. We're going to look at RGW multi-site in 1 second. Resource consumption is improvements in the use of space when storing small files. And there are reliability improvements when performing recovery for EC storage pools. So here, a significant effort has gone into improving RGW multi-site capabilities. This is not a new feature, but it is work in making it more efficient for very large clusters. We have a significant customer that has a cluster that is approaching 50 petabytes in size, and they want to use RGW multi-site and in that super cluster. So the scale and reliability work going into it are targeted at making it resilient at this unprecedented level of scale for this bit of functionality. On the efficiency front, the BlueStore minimum location size has changed for SSD in Nautilus and for HDD in Pacific. And this is resulting in significant improvement in the allocation of small files as defined as files smaller than 64K. This is part of a group of features that internally we call BlueStore V2, which is a collection of enhancements that have rolled into BlueStore since BlueStore originally went GA. Similarly, another RADOS level enhancement is the introduction of more robust erasure coding recovery that only requires K shards as opposed to K+1 shards to recover. And the business benefits here are obviously for better data availability, and better recovery scenarios, even where before it wasn't possible or at multiple locations, better resource consumption or better allocation of resources. There is also an interesting scenario for object offload to public cloud that is currently targeted at the 5.1 release. So we will be discussing that during the summer. And finally, I'm going to leave you with a one-slide summary, cheat sheet of everything that's in here. We covered pretty much everything except the Messenger v2.1. Messenger v2 was introduced with release 4, and it provides encryption support for the Ceph backend protocol. This is particularly interesting to customers that decide to encrypt all network traffic, even when it's on a secure network. And so there are some enhancements in v2.1, notably the introduction of kernel support in recent RHEL releases that round up that scenario for customers that have internal encrypt everything no matter what policies. And on that note, I'm going to hand over to Sage to discuss what is coming next year upstream. To remind you, our HCS 5 is shipping this July. Ceph Quincy is going to be the basis of our HCS 6, and we're moving to a fixed schedule or semi-fixed schedule where upstream is targeting February, March for the upstream major release of the year, and downstream is targeting May, June as the enterprise support release corresponding to that. Sage, take it away.
All right, thank you, Federico. My name is Sage Weil. I'm the Ceph project lead, and I'm going to give you a sneak peek of what is coming in our next upcoming release, Ceph Quincy, due out next March. So just a quick brief refresher on how Ceph upstream releases work. We release every year with a stable named release. We maintain the last 2 such releases with backports for bug fixes and security updates, and you're able to upgrade up to either jump 1 release or 2 releases at a time. So essentially you have a 2-year window before you can upgrade or need to upgrade. And as Federico mentioned, this most recent Red Hat Ceph release is based on Pacific. That came out just this past March. And I'm going to be talking about Quincy, our next release, which is coming out next March in 2022. So I'm going to break this down into sort of 5 high-level themes: usability, quality, performance, multi-site capabilities, and community ecosystem. And I'll start out with usability. So a lot of the work on the usability front has been focused on deployment and management of Ceph clusters to make Ceph simply easier to use. And that falls into 2 categories. There's the Ceph ADM, the new Ceph ADM orchestration tool, which is built into Ceph and deploys Ceph on bare metal using containers. And then there's the Rook deployment tool, which deploys Ceph inside Kubernetes. So on the Ceph ADM front, we have a number of things in the works. One is streamlining the way that you bootstrap RGW multi-site federated configurations. We're going to be adding support for SMB, so you can export CephFS to Windows machines. In Pacific and HCS 5, we added support for an ingress controller, which is basically high availability HA proxy and keep-alive-D for RGW. That's being extended to include NFS, and we'll also include SMB once that's available, and eventually other managed work services like the dashboard and Prometheus endpoints and so on, the REST API that's built in there. A lot of the effort, though, over this next cycle is going to be around improved scalability, so that when you have very large clusters with lots of hosts, the management sort of tooling for deploying and so on is still nice and responsive. And improving some of the scheduling there too, so that when Ceph ADM is deciding where to run a daemon, it'll take resource utilization into consideration, like how much memory is available in CPU and so on. And some other automatic configuration around automatically tuning the memory usage of MDS and monitor daemons. On the Rook Kubernetes side of the house, there's most of the focus here is on improved orchestrator and dashboard integration. That basically means that if you're approaching Ceph from the Ceph side of the house using the Ceph CLI or the Ceph dashboard, you'll be able to control and have visibility into the deployment versus managing Ceph from the Kubernetes side of the house using the CRDs. We'll also be adding support for ingress controllers for SMB, some improved management around how OSDs and devices are managed and deployed, both on the AWS context, we're using things like EBS, and on the bare metal side of the house, where you have actual physical devices. And of course, lots of testing here. On the dashboard front, a lot of work has gone into this over the past couple of years. Quincy will be no exception here. Sort of in the first category is a series of cleanups and improvements. For day one, for example, when you first install the cluster, there's going to be a wizard for helping to get things initially set up. And then sort of a whole bunch of improvements for usability, improved performance, things like pagination, sorting, and so on. And then a smattering of support for additional features. So things like RBD snapshot mirroring is new, that'll be exposed in the panel. Improved visibility and control of RGW multi-site, another RGW advanced features. CephFS mirroring is new in Pacific and will be improved in Quincy. That will be surfaced into the dashboard as well. Things like snapshot scheduling, subvolumes. The CephFS top feature that Federico just mentioned will have a dashboard variation, so you can see it via the GUI instead of in a terminal. And then also the new features that are coming in Quincy will also be surfaced through the dashboard in that same release. So things like managing the new QoS features that are coming, the Ingress controller I mentioned, and the ability to do some customization around alerts and Grafana dashboards are coming as well. And then once you sort of dive more deeply into the components, there's just a smattering of usability improvements for sort of the Ceph innards. So for Rados, the low-level storage layer in Ceph, the MCOC scheduler is a key piece of the new QoS work that's been ongoing. That'll be enabled by default, which will eliminate some of the fine-tuning that some users have to do in order to control background versus foreground I/O, and some automatic benchmarking to make that much easier to use. The PG autoscaler is something that we introduced several releases ago to automatically manage how data is sharded across the cluster, so the system can operate more hands-off. We're going to be introducing different modes. And the main goal there is so that when you deploy a fresh cluster and create a pool and immediately start hitting it with a benchmark or a workload, you'll be able to take advantage of the full throughput instead of waiting for the cluster to sort of realize that that pool is going to consume the whole system and then spread it out. And some other things are being improved as well around the balancing and utilization across devices and the way that we surface the statistics when we show you when any of the data in the system is degraded, has fewer replicas than you want. We'll tell you how degraded, so you can tell if it's something to worry about or something to really worry about, essentially. A smattering of other usability improvements across other components. So for RBD, for example, some of the older scripting is being replaced with more modern scripting with systemd. On the SuffFS front, things around memory configuration and support for snapshots that apply to groups of subvolumes and not just subvolumes themselves, which is something I think is relevant for Manila. I'm not quite sure. On the Rados gateway front for object storage, some CLI improvements to sort of unify things under one set of commands. Some automating some of the configuration with the dashboard so things work out of the box without having to understand what's going on with the detailed options. And there's also this ability to coming that will allow you to view your block devices in the cluster and the snapshots taken of them and access that via an object interface for ease of use, download, and so on. Moving on to sort of the quality bucket, general quality and robustness. We're going to go bottom up this time, starting with Rados. So these are a lot of sort of issues that some customers have hit in very large clusters or with very extreme workloads that we've identified and been fixing over time, and we sort of been structurally improving under the covers. So things like dynamically adjusting the rate at which things are trimmed out of the monitors, improving the deletion of placement groups, the performance there when data is migrating across the cluster. One phase of that is getting rid of the old data. Things like that are being improved. Scalability in the manager. Oops. Sorry, looks like things jumped back. Scalability in the manager, so that we auto-tune some of the thresholds so that we're ingesting metrics from all the different daemons at a proper weight without overloading ourselves. And better logging around slow operations if some extreme workload is causing certain OSDs in the system to be backed up. On the Rados block device front, there's some improvements here and a few features. So client-side encryption has been something that's been added recently. Support for here is being extended to clones, so you can have clones or images, and the clones of those images have different encryption keys and have that work properly. The ability to import and export consistency groups, sets of images that share the same snapshots, and improvements to the new write-back cache that was added in Pacific are coming. RBD NBD is a component of RBD that allows you to use sort of the latest librd-based code with all the latest features with an efficient pass-through into the kernel, so you can get a kernel block device. Some improvements here allow you to have a single daemon that manages multiple images and to restart that daemon, mostly to support the Ceph CSI project, so that we can sort of unlock some of these features in a Kubernetes environment and make them available there. On the CephFS front, a number of improvements. So CephFS Mirror is something that's new for mirroring data across Ceph clusters that was introduced in Pacific. Lots of improvements there coming in Quincy to allow that to support scale out and HA and so on, so it performs better in real world environments. Scrub scheduling or scrubbing is something that's been supported for a while. This is simply adding sort of automatic scheduling, so your system will scrub in the background on its own without you having to ask it to. A few features here, like immutable file support, the top command allowing that to support multiple file systems. And of course, there's an ongoing investment in expanding the test coverage to ensure that the quality of the CephFS code is continually improving and we're not introducing any regressions. I think the one other thing here to mention is investments in the underlying lab infrastructure that we use to do all the testing and development upstream. This is the Ceph lab. There's a whole pile of new hardware that was recently donated by the Ceph Foundation. Thank you very much to those people, those organizations for supporting this work. That includes expanding the Ceph cluster within that lab that we dog food, more build machines to lower the turnaround time for developers to get their code tested, and a much more test nodes as well. There's a whole bunch of improvements to Teuthology, which is the testing framework that we've built to test Ceph and other distributed environment that are probably too detailed to get into here, but essentially making that lab operate more efficiently and ease life for developers who are contributing to Ceph. Probably the most important thing to mention here, though, is that we are adding downgrade testing with the Pacific release and with Quincy, so that we'll be verifying that if you upgrade a point release and then downgrade again because you hit some issue or for whatever reason, Ceph will continue to operate as expected. This is something that generally should work, but it isn't tested, and so until you test it, you never really know. We'll be adding that over this next year. Performance. So the biggest theme here is around quality of service. This is something that we've been investing in infrastructure for some time now, but we're sort of finally seeing the fruits of those labors. There's significant improvements in the mClock implementation in the OSDs that allows us to prioritize background work versus foreground work. As I mentioned before, that's going to be turned on by default. And there's this profile concept that allows us to also do things like prioritize traffic between different pools. And eventually, hopefully in the Quincy timeframe, we'll finally add that last sort of missing piece to unlock this so that you can prioritize client versus client I/O and specify minimum IOPS, for example, for a particular client, which has sort of been the end goal for some time, but it's taken a long time to get there. And of course, with Quincy, we would like to have all of this surface in the dashboard so that you can actually manage these new features in a nice, easy, intuitive way. Blue Store is the library that we use to store actual bits on actual storage devices on all of these hosts. Ongoing improvements there, of course, in the performance front. The biggest development here is this realization that we could skip sort of the detailed tracking and recording of allocation metadata for every I/O, and instead only rebuild that information on demand if the OSD failed unexpectedly for some reason. This will significantly improve performance for normal I/O at the small cost of introducing a slower startup when the OSD does fail and have to recover. So we're excited about that. And a couple other improvements here around our cache and memory management. And this tool that's coming shortly, that is sort of a targeted benchmarking tool that looks at just one aspect of when key value data is stored within OSDs. Previously, when we were benchmarking this, you'd have to set up Rados Gateway and set up a Rados Gateway benchmark, and it was troublesome. So these people who are trying to identify performance bottlenecks in the system will have a more targeted benchmarking tool that will make that available. And hello to the small one. On the Rados Gateway front, lots of work coming here. Sort of the most exciting bit that we'd like to have, at least in experimental form for Quincy, is deduplication support for Rados Gateway. There's ongoing work in Rados Gateway for several years now. I'm doing a lot of refactoring and code cleanup. In Quincy, this is manifesting as finally switching over the way a lot of the metadata in the system is stored in a more appropriate structure, so it'll improve the overall performance and efficiency of the system. S3 Select is something that we've added in either Octopus or Pacific, I lost track, that supports analytics workloads like those coming from Spark on top of object storage. we've added support for the Parquet file format. It's coming in Quincy versus I think it's CSV currently in Pacific and Octopus. And there's some caching infrastructure in Rados Gateway that is continuing to improve and expand to include new capabilities that we're excited about as well. I'll mention telemetry here too. So telemetry is an opt-in capability where users can choose to share information, high-level, non-identifying information about their cluster with Ceph developers so we can better understand how it's being used in the field. We're going to be adding a new channel that you can optionally turn on that will give us more granular performance data so we can find out how big your IOs are, what kind of load the system is under, so we can better understand what workloads real users are experiencing in the field. So that when we're making decisions around tunables or design decisions for future versions of Ceph, we can do that from a more informed position because we'll actually know what people are using the systems for. So we're excited about that. And of course, the biggest thing going on in performance is Project Crimson. This is a multi-year project that is essentially rewriting the entire data path for Ceph, particularly focused on the OSDs. Essentially moving us from a more traditional model where we have threads and mutexes and work queues and so on to a more modern architecture based on a framework called C-Star, where you do run to completion, we pre-allocate cores, and we're able to take advantage of libraries like dbtk and sbdk that allow us to pull NVMe and network drivers directly into user space and run with fewer interrupts and so on. Essentially, the goal here is to have a much lower CPU cost per IO, and in turn, allow that to translate into much higher IOPS. So Crimson is a long-term project, but we have certain milestones for Quincy. The focus has really been around fully supporting RBD workloads. And so in the Quincy timeframe, we expect to have scrubbing working, full support for snapshots, multi-core support. And so the big item here is C-Store, which is the new written from scratch storage backend that will replace BlueStore for the Crimson-based OSDs. Should be sufficiently feature complete to actually use it and do real performance tests and reliability tests and so on. So we're excited about that. Moving on to multi-site clusters. So the newest entrant here is the CephFS mirror capability that was added in Pacific. This allows you to do snapshot-based mirroring of directories in CephFS to remote CephFS clusters in other data centers and time zones and so on. In the Quincy timeframe, we're going to be adding that high availability scale-out support to that daemon. And we're also going to be improving the efficiency of incremental updates so that we're transferring fewer bytes over the wire. RBD mirror has been around for a long time now, for many releases. And recently in Octopus or Pacific, I'm forgetting, we added support for snapshot-based mirroring in addition to the previous journal-based mirroring. This is extended in Quincy to include consistency groups, which are sets of images that sort of share coherent snapshots so that you can have those mirrored as a unit to a remote cluster. And there's some sort of backend improvements around the monitoring and metrics so that we can have proper visibility into how well RBD mirroring is working and performance and so on. On the RGW multi-site front, this is always a lively area with lots of things going on. Dynamic resharding and multi-site is work that will be landing in the Quincy timeframe, which is sort of an intersection of two different features capabilities that has been problematic for a while now, but we're finally getting sorted out. More on the feature side, though, we're adding lifecycle transition to the cloud. So lifecycle management is this idea that after objects have been in the cluster for some period of time, they automatically get moved to a different tier or even deleted after some period of time and so on with this policy. That will include the ability to push those objects to cloud storage. Zipper is a project that is refactoring a lot of the internal RGW interfaces so that we can reuse them in new and interesting ways. Those will include policies that can be implemented in a Lua scripting language. So you can have more dynamic behavior for how your S3 buckets are going to behave, particularly in the sort of multi-site world. And then we also expect to have an initial prototype of sort of a database backend for metadata. This is sort of almost a proof of concept just to make sure, demonstrate that we've done the appropriate refactoring internally, but may have certain applications in edge deployments. And finally, there's also going to be this ability to sync from buckets that are stored in the cloud using a combination of like Lambdas for event notifications and so on. So that's exciting, being able to sync both to and from the public cloud from Red Hat Scalable buckets. And finally, I'll talk a bit about the ecosystem and community for Ceph. So there's some sort of behind the scenes efforts that maybe aren't too exciting, but just improve the world overall. Things like automatically updating the Ceph documentation so that all Ceph config options, the documentation matches the actual reality and don't get out of sync. Telemetry has long had this ability to phone home crashes when you opt in, of course, so that we can identify which bugs users are hitting in the field. That information is being integrated with the upstream bug tracker so that it will automatically open tickets in a bug tracker to provide better visibility and tracking for developers so that we can ensure that we're properly prioritizing and allocating our efforts around issues that actual users are actually hitting in the real world to improve overall quality. So we're very excited about that. Of course, there's an ongoing interest in supporting new hardware devices as they become available. So ZNS SSDs are perhaps the most exciting thing here. This is a new class of device that is just hitting the market now. So these are very dense SSDs with lots of storage, but as a result, they have very, very large erase blocks, and they have this new type of interface where you have to write big sequences of data sequentially and then delete them sequentially, kind of like an SMR hard drive, but based on flash. So this is a key focus for Crimson's C-Store backend. And it's sort of the primary type of device that we expect to be used heavily within the next couple of years. Multi-actuator HDDs are something that has just recently hit the market. These are essentially traditional hard drive packages, but instead of having a single set of arms that swing across a bunch of platters, they're separated into two different independently operating sets of heads. So you essentially double the IOPS in the package. Ceph just treats these as two independent OSDs, but with a shared failure domain. So there's some support that'll land in Quincy that makes these work sort of properly and sanely. And of course, we remain interested in making sure that we can effectively use persistent memory. This will be well supported, but not required by Crimson. But there's also new support in Pacific for using this for the RBD client-side write-back cache. That's a little bit experimental right now, but will be better supported and robust within the Quincy timeframe. NVMe fabrics are something that we hear a lot about. In the Ceph world, we sort of break this down into two worlds. One is the client side, essentially talking to Ceph Storage over a fabric. And the key piece here that we're building is essentially an NVMe over fabric gateway to RBD. So the NVMe fabric would essentially take the place of using legacy protocols like iSCSI. And there's also this possibility of leveraging some newer specialized hardware, SmartNICs like NVIDIA's Bluefield, so that you could actually move this gateway functionality onto a card within the same host. So you could present an NVMe device over the PCI bus to the hardware, but you would have the librd translation code running on that card and librd going over the network. So this is something that we're investigating and interested in. Totally independent of that, there's also a more far-reaching future discussion around how we can leverage NVMe fabrics within the Ceph cluster itself on the back end. So after we sort of complete the first phase of the Crimson rewrite and sort of unlock the performance due to that, we'll be looking at how we can leverage an NVMe fabric so that the primary replica OSD can write directly to the storage device on the replicas without sort of involving the CPU on those other hosts. And this is mostly about just performance and avoiding any interrupts and getting those additional replica CPUs involved in the I/O path. But that's a much longer term conversation. We of course continue to invest in integrations and adjacent ecosystems that are maturing. So things like Rook. There's, as I mentioned, ongoing improvements in the integration, the level of integration with the orchestrator and the dashboard. Serverless has been something that we've seen a lot of interest in, and most of the work on the Ceph side has been around event notification for Rails Gateway, so we can feed, upload, and events into Kafka and AMQP and so on. Spark is very interesting, particularly when people are running analytics workloads on top of Ceph. S3 Select, I mentioned, is sort of the key investment there. And of course, we're continuing to invest in interoperability with the public cloud, particularly when it relates to object storage. Some of the newer projects that are on the radar are Apache Arrow and the Parquet file format. And these are essentially data interchange formats that are increasingly being used, and we want to make sure that they can be used appropriately and efficiently with Ceph as well. So ongoing investments there. I'm going to give a really brief update about the Ceph Foundation and what they're up to. So as many of you probably know, the Ceph Foundation is an organization that allows lots of industry stakeholders to pool financial resources to support the Ceph project. I just want to call out a couple of new members of the foundation in addition to the founding members. So Bloomberg joined within the last year and a half. And among the general members, Vexhos is one of the more recent members to join as well. And of course, we also have a number of associate members. These are nonprofit and government institutions that are heavy users of Ceph and involved in the community and involved in the foundation work as well. But the current projects of the foundation, how we're actually spending that money, a lot of that is being invested in Ceph documentation. We have a full-time technical writer that's updating and improving this quality of the Ceph docs. We're also undergoing a complete update of the Ceph.io website. This effort has been spearheaded by SoftIron. Big kudos to them for getting this project off the ground. We plan to launch that new website in the next month or so that's exciting. There's also a new effort, collaboration with the Linux Foundation Training Group to build free online course material that trains users about how Ceph works and how you can use it and so on. We'll be starting out with some initial courses, but we expect to expand that catalog later as we have the time to do so. So that's very exciting. A few other projects, mostly on the infrastructure side. We pulled a lot of the things that we were running on sort of the back-end build and CI out of the public cloud and into the lab by buying dedicated hardware, significantly reducing our recurring costs. So that's good. And as I mentioned earlier, we've bought a whole bunch of new hardware to expand that Ceph lab. So we're very excited there. Probably one of the most exciting things that the foundation has invested in is taking over this contract with Cloudbase that has developed initial versions of RBD and CephFS for Windows. So these are native Ceph drivers for block and for file that are now available and will soon be available directly from the Ceph.io website. So we're excited about that. And the last thing I'll mention is that there's a new marketing committee being kicked off, essentially so that key stakeholders can coordinate the overall marketing activities around the Ceph project. And that is just getting off the ground. ARM is something that we've talked a lot about over the years. We sort of reached some key milestones this year, and no small part thanks to hardware that's been donated by Ampere. We're doing all of our builds and releases for every test build is being conducted on ARM as well. And we're now generating both packages and container images for ARM, so you can install Ceph ADM-based clusters on ARM systems, including Raspberry Pi or whatever it is. On the telemetry front, so I mentioned telemetry before. I just want to call out that there is a public dashboard that allows you to track all this information. So in this example, for example, you can see as new releases come out, people upgrade to those releases. We now have more than 1,000 clusters phoning in, and these dashboards allow you to dig into all sorts of interesting details about how big they are, what kinds of what versions they're running, how quickly they upgrade, and so on. There are multiple channels of that telemetry. Of course, all of this is opt-in. We're very transparent and very conscientious about what we include and making sure that users consent to it. And we're very interested in all feedback there. But we're collecting things like what version of Ceph you're running, how big your cluster is. If Ceph daemons crash, we figure out where in the code it crashed, so that we can feed that into the tracker and make sure that we're focusing our stability efforts around the issues that people are actually seeing in the field, even without them emailing us or complaining on the mailing list or tracker or whatever it is. We also collect information about the models and vendors for devices. So if you're building a new Ceph cluster and you're wondering what type of hard drive you can use or what other people are using, you can visit this dashboard and you can see all the raw numbers around what other people are using, which can be very interesting and helpful. And as I mentioned before, we'll be adding some performance information here as well that users can opt into if they'd like to help us out in understanding those types of workloads. In a recent Ceph survey, we asked whether people had telemetry enabled. We're happy to say that roughly a quarter of the respondents already did, at least for some of their clusters, more like a third if you include some of them. Many people still haven't enabled telemetry though, and we asked why. In many cases, this is because the clusters are on private networks that don't have direct access to the internet. It turns out that telemetry supports the use of a SOX proxy, so this is usually something that's pretty easy to get around. But a lot of people simply haven't enabled it because they just haven't gotten around to it yet. So consider this your reminder nag to go do so, because the developer community really does value this information, as it gives us a much better insight into how Ceph is being used and how we can improve it into the future. So looking beyond 2022, beyond this Quincy release that we're building now, will come the R release. We haven't named R yet, so if you're interested in being involved in that decision, please visit this URL to make your vote heard, because if you don't, it is possible that Ceph R will be named after Seth Rogen, a Pacific octopus in the, the Vancouver Aquarium, named after Seth Rogen. So this is your chance to make your voice heard. Anyway, thank you very much for listening, and enjoy. Thank you.
Thank you, Sage. And unfortunately, there is no interactive session. This is pre-recorded, but you can find both of us on Twitter and send us questions there. You can contact the commercial team through the Red Hat website for more commercial inquiries. And we're relatively easy to find. So if you have any questions, send them our way.
Thank you.